So next, Zubair will tell us about detecting anti-ad blockers in the wild.
Can you guys hear me? Okay. So this is joint work with Haris at UIUC and Zayun at University of California, Riverside. So this work is about this tussle between ad blockers and anti-ad blockers. And we try to do a scientific measurement study of how this thing is evolving. So I don't want to preach to the choir, but I do want to give some background about ad blockers. So online advertising enables the free web. So the assumption is that users agree to watch ads to support these free services and content. According to IAB, which is a consortium of advertising companies, the annual online advertising revenue was more than $70 billion in 2016 alone. However, the economic magnetism of online advertising has made it susceptible to different types of abuses. And one of the big issues with online advertising has been malvertising. So there have been several reports and papers which have shown that hackers use online advertising and to send out malware to a large number of people. Another major issue with online advertising is intrusiveness of the ads. Oftentimes these ads are really intrusive. They actually distract users from the content, or it is very hard for users to access content. Another big problem is performance, and there have been some work which has shown that if you remove ads, you can get a significant speed up in your page load times. So these ads and trackers on websites, they're really slowing down page load performance. And last, but certainly not the least, the big privacy concern. Some of this was also mentioned in the last presentation. Online advertising relies on large-scale tracking of users across the web if they want to show targeted ads to people. And this obviously leads to a serious privacy and surveillance concern. So there are different tools people use to protect their privacy and mitigate some of these concerns. These tracker blocking tools like Ghostery, Privacy Badger, these are really popular among people. And these tracker blocking tools specifically block trackers. They do not block ads most of the time. Another set of tools which are a little much more popular than tracker blocking tools are ad blockers. So there are these tools like browser extensions like AdBlock Plus, uBlock Origin, my personal favorite, which not only can block trackers, but can also block ads. And I would also like to give a shout out to Brave, who are actually also sponsors for pets. And they actually have a browser which has an ad blocker built in, and they also block a bunch of trackers as well. So these ad blockers are actually really popular. There have been different studies to measure how many people use ad blockers. There have been some reports which show that more than 600 million people around the world use ad blockers, and this number has been increasing over time. There was a paper in IMC a couple of years ago which showed that 22% of users in a European internet service provider used an ad blocker. Last year, there was a paper in IMC from ComScore which showed that 18% of users in the US use an ad blocker, and ad block usage is high in specific demographics. For example, if you specifically focus on users who are between ages of 18 and 34, 50% of users in Germany and about 30% of users in US and UK use an ad blocker. So this means ad blockers have like substantial penetration already, and their deployment is expected to increase over time. So before I go into some details and talk about how anti-ad blockers work, I want to give a quick update, quick overview of how ad blockers actually work. So as it was mentioned in the last presentation, a lot of these tracker blocking tools and ad blockers tools as well, they rely on these crowdsourced filter lists. So for example, EasyList is one of the crowdsourced blacklist which is used to block ads. There is another list called Easy Privacy, which specifically targets trackers. And then some of these ad blockers also support these so-called acceptable ads whitelists. And these whitelists are used to actually let in some of the good ads through. And these filter lists actually have two types of like regular expressions that they use. So first, they can actually specifically target network requests. So they can actually have regular expressions which match against HTTP URLs. They also have regular expressions which target specific HTML elements for ads or trackers. So obviously, online advertising industry and many publishers obviously do not like ad blockers. So they actually try to come up with ways to defeat ad blockers. And one of the ways they actually try to do countermeasures to ad blockers is to manipulate their ad delivery to slip ads pass through ad blockers. So for example, they can manipulate the URLs from which these ads are served, or they can manipulate HTML element properties to defeat the regular expressions. And remember, these filter lists are open source, so it is actually relatively trivial for many publishers to actually do this kind of countermeasure. However, there are not many publishers who have used this countermeasure. There has been also some research which has shown that these kind of manipulation techniques can be dealt with. For example, there have been some folks in Princeton who have done research on perceptual ad blocking. So because ads have to be distinguishable from actual content, so you can leverage this fact and develop a perceptual ad blocker which can separate out ads. So you may not actually have to rely on regular expressions to block ads. Our focus in this paper instead is on anti-ad blockers. So these are techniques that publishers use to detect whether or not a user is using an ad blocker. And then if they detect that the user is using an ad blocker, they ask users to disable the ad blocker or whitelist the website. These anti-ad blockers are implemented using simple JavaScript logic. And most of these anti-ad blocking scripts the logic can be divided into 3 simple steps. So the first one is a timeout. So before anti-ad blockers run on a website, they actually wait for ad blockers to run. So here is an example of a website which has a couple of ads, display ads here. So when ad blockers run, these ads are removed. And this is when anti-ad blockers would trigger. So there is a timeout condition. This is generally a few seconds. And after the timeout has triggered, they check different properties of the ads. For example, they might want to check whether ads are visible. And if ads are not visible, many of these anti-ad blockers, they show these notifications to users saying that, hey, we think that you're using an ad blocker, please turn off your ad blocker or whitelist our website. So there is this lot of anecdotal evidence that many websites are using anti-ad blockers. How has their number evolved over time? What that number actually is, this is relatively unknown. And the goal of the paper is to develop an automated methodology that can be used for large-scale measurements of anti-ad blockers. So here is an overview of our methodology. So it can be divided into 4 steps. So I will kind of walk you through this. So our basic idea is that we are going to do A/B testing. So what we do is we first open a website without an ad blocker. Then we open the site with an ad blocker. And we automate this process using Selenium. And then what we do is we identify a bunch of features from DOM of a web page. And remember, our intuition is that these anti-ad blockers are doing visible changes in response to ad block detection. So hopefully, if we can capture these visible changes by using some of these DOM-based features, we can capture whether or not a website is using an anti-ad blocker. Then we do standard machine learning stuff. We throw in all these features to a standard machine learning classifier, like random forest, SVM, or some Bayesian approach. And then we test any unlabeled website using this machine learning classifier. So just to give you some more sense about what these features really are. So we have a bunch of features. There are a lot of details in the paper. Here I would like to emphasize on 3 types of features. So first is whether or not there are any changes in number of DOM nodes of a web page. And we looked at things like number of div nodes, number of iframe nodes. And the distribution here is showing you the change in number of div nodes. And what we note here is when anti-ad blockers operate, they actually inject some new nodes in HTML content of a page. For example, they introduce those divs, those notifications, which ask users to disable their ad blocker. And some of these features are fairly distinguishing and can be used for accurate classification. Some other features that we look at are style changes, whether the visibility of content is changing on the page. Some of these features are really impactful. We also look at the textual content of the page and do that comparison. So once we use these and a bunch of other features, we had a small data set which we manually labeled. And we had about 200 positive samples, about 1,000 negative samples. And we used standard 5-fold cross-validation. And we are able to get decent accuracy. So more than 93% accuracy for random forest classifier. Now that we have this classifier which has been trained and tested on a small scale data set, we actually now want to do a large scale measurement study. So we are going to take this machine learning based approach and we are going to run this on Alexa top 100,000 websites. And this study was done in February 2017. So this was like a single point study that we did for this paper. And when we ran our experiments, we actually did try a bunch of different configurations of ad blockers. So basically, ad blockers filter lists can be configured differently, and we were expecting websites to respond differently depending upon the configuration of ad blocker that we used. So if we use the default configuration on AdBlock Plus, which was to use easy list and acceptable ads, we were able to detect 556 websites out of 100,000. When we changed this configuration to remove acceptable ads, the number increased, but not by a number that we were actually hoping for. Another thing we noted was that the easy list itself actually contains a bunch of rules which target anti-ad blockers. So this cat and mouse game is actually escalating really fast. So if we get rid of those rules, the number of websites actually shows a decent jump, and we get about 686 websites. Now you may think this number of websites is actually not a lot, which I would agree. But I want to point out that one of the limitations, or this is actually something we are doing by design, is we are only identifying websites that visibly react to ad block detection. So if a website detects an ad block user but does not visibly react, we are not counting that as an anti-ad blocker. We also wanted to analyze responses to ad block detection. So we first look at the aggressiveness of the notification, which was shown by the website. And we find out that a lot of these websites actually show non-intrusive notifications, meaning users can dismiss these notifications. However, there are some websites, about 165 websites, which show really intrusive notifications, which actually cover a lot of content on a page, and they cannot be dismissed by users. We also did some content analysis of the notifications which were shown by these websites, and we found out that about most of these anti-ad blockers, they ask users to disable the ad blocker or whitelist the websites. Interestingly, a bunch of websites are now asking people to donate some money or enroll in some paid subscription model for the website. We also looked at which websites were doing these anti-ad blocking, and we looked at different categories of websites. And as expected, news and blogs websites are the worst offenders for anti-ad blockers. They dominate websites which use anti-ad blocking. Finally, we also wanted to analyze how these anti-ad block scripts are themselves working. So what we did was, once we did our large-scale analysis for each of the website, we extracted the JavaScript, and we wanted to do some systematic analysis. So what we ended up doing was we extracted these JavaScripts, and we decided to actually cluster them. So we didn't want to individually analyze these JavaScripts. So idea was that if we can cluster them, we can hopefully analyze those individual clusters, and maybe we can group together JavaScripts which have similar behavior. So we took the JavaScript code and we converted them to abstract syntax trees, which is like a fairly standard thing to do. And then there are some details in the paper. We used PCA and a bunch of other approaches to cluster these JavaScripts into different anti-ad block JavaScripts into different clusters. So here is, so we actually found a nice dichotomy. So you actually had one big cluster of most of all the scripts which were served from the first party. So meaning if you go to New York Times, and if New York Times actually shows you an anti-ad blocker, the script is downloaded from New York Times. And then you also actually have dedicated third-party anti-ad block services which actually serve a large number of websites as well. But these first-party scripts actually nicely clustered into one group. And when we analyzed some of these first-party scripts, they were all actually fairly simple. So they follow the same logic. So for timeouts, they generally use a fixed timeout. So for example, in this example, they are using 2,000 milliseconds. They have a fairly simple detection logic. They're checking different properties of HTML elements. And they have like a fairly simple response mechanism. When we looked at some other clusters, most of those more sophisticated clusters belong to third-party scripts. So these are from companies which have dedicated anti-ad block services. And you can see a bunch of popular players like PageFair. There is a community script released by IAB, which we also found, and a bunch of other third-party scripts. Now, important thing to note here is that these third-party scripts are much more sophisticated. So for example, instead of having a fixed timeout, they have a dynamic timeout, or they do continuous and periodic checking whether or not a user is using an ad blocker. To detect whether or not user is using an ad blocker, they actually have different detection logics. In addition to doing passive analysis of ad properties, they also inject baits. So they do some active deception. So for example, there is a page-fair script which adds a div or a script which seems to be an ad, and they would expect the ad blocker to detect this. So these are some of the techniques which are also used. They also try to see if the ad blocking extensions are leaking some extension resources that they can catch. And finally, these third-party scripts not only allow publishers to show a notification to a user, but they also allow publishers to show ads to users who are using an ad blocker. Some of these third-party anti-ad blockers, they are part of the acceptable ad program. So if they detect that the user is using an ad blocker, they would replace regular ads with acceptable ads, which can bypass ad blocker. There are a lot of details in the paper. I would encourage you to go and read the paper for a lot more insights. So we have been following up on this research. So some of the interesting things that we are doing is, instead of only doing a point measurement of anti-ad block deployment, we are now planning to do a large-scale longitudinal measurement. So we can actually see how this landscape is evolving over time. We're also working to improve ad blockers. So we are trying to develop automatic ways to help ad blockers to circumvent anti-ad blockers. Finally, this space is actually really changing fast. There are a lot of startups. There is a lot of movement from different players in the industry. For example, Safari is planning to include a tracker blocker by default. Interestingly, Chrome is planning to include an ad blocker or like an ad filter in the browser, which sounds counterintuitive, but there are some interesting things happening there. And finally, there are some regulatory things which are going to impact ad blocking landscape. For example, GDPR regulations will go into effect next year, and they will have an impact on ad tech, which relies on large-scale tracking of users. So I will conclude with this interesting thought by Doc Sills, and I would like to thank our sponsors, Data Transparency Lab and National Science Foundation. Thank you.